Hey Professor Heck, I'm Josh Miller. This is my statistics project. So my article chosen was we watched 906 foul balls to find out where the most dangerous ones land. So there is no central database for MLB's foul balls, so the writers of this article did their own sample of 906 foul balls over 10 games in the season that had the most fouls and had to see for themselves where each ball landed and how fast they were going. The purpose of this extensive research was to see what areas of the baseball stadium are in most danger of being hit by foul balls. Along with placement of these foul balls, they attempted to measure the exit velocity of each ball hit and could on over half of them. So where do most foul balls land? The highest concentration of foul balls land in section 1, showed in dark blue, that little space in the bottom middle, with about 40% of all foul balls landing there. Areas 1 through 3 typically covered with a net, blocking most foul balls. However, they can still go over the net and in some cases through the net. And as you can see, there are a lot of fatal injuries that can happen with foul balls, so it is really important that you be careful. Just a couple years ago, a 79-year-old woman died after being hit in the head at Dodger Stadium, and multiple other injuries that send people to the ER occur. So you got to be really careful. So the hardest hit fouls seem to land in the most unprotected areas. Now this chart you can see here is foul balls by the stadium zone they land in and their exact velocity among 906 fouls hit this season in the most foul-heavy day at the 10 MLB stadiums that produced the 5 most fouls of June. It's a lot. Now, as you can see, a majority of them land in an area not protected by netting, and just about every single one of them that are above 90 miles per hour land in this zone. All of them are in sections 4, 5, 6, and 7. So you can see in the little chart below, are not covered by net, and all the balls that travel fast go under this category. So my question is, the mean exit velocity of fouls hit in the left field from third base to the fence, section 4, significantly higher than the mean exit velocity of fouls hit in the right field from first base to the fence, section 5. So here are my descriptive statistics, where I used a t-test to do this with a null hypothesis, mu1 equaling mu2, and an alternate hypothesis, mu1 being greater than mu2. So as for left field fouls, the sample is n equals 13, n being the number of fouls hit into left field, the average being how fast each ball is hit in miles per hour, being 91, and the standard deviation in left field fouls is 11. And for right field fouls, n being foul balls hit into right field is 14. The average of how fast balls are going is 80 miles an hour, and the standard deviation is 10. So the results of my calculations are that t is equal to 2.453 and that p is equal to 0.015. Now, do we reject or fail? Of course, since 0.015 is less than 0.05, we reject the null hypothesis. And is there enough evidence? There is enough evidence to conclude that the mean exit velocity of fouls hit in the left field is significantly higher than the mean exit velocity of fouls hit in the right field. Now here is my Excel chart giving you just a visual of how fast the balls were hit, the left being shown in blue and the right field being shown in the orange. And as you can see, the blue lines are pretty much across the board higher, meaning that yes, we can see that the balls in the left field do have a higher mile per hour speed than those hit into the right field. Thank you so much.